Okay, let's start. Just look at A for right now. 7 to the negative 2. So does everyone agree that this is really over 1? All numbers are always over 1? So since it's in the numerator now, I'm going to bring it down in the denominator. I've just moved it. Now if there's nothing left up top, there's really a 1. So after I moved it, it's empty, but there's really always a 1 there. Okay? And by the way, what is 7 squared? 49. If they're little like that, go ahead and multiply it out. Now there is no line in the sand as to what's little, what's big, because you can't really establish that. But in the book, sometimes they'll multiply it out, sometimes they won't. If it's big, don't multiply it out. If it's 5 to the 11th, don't multiply it out. 5 cubed, yeah, we can do that. Okay, so kind of use your best judgment. Okay, so over here, this number, negative. So right now it's over 1. I'm going to move that negative 3 on down. So I'm going to have negative 3 to the 4th. Now up top is still a 1, because when I moved it, it's empty, but it's really as a 1. Notice I left the parentheses, but the only thing that changes when I move it, it's no longer negative. Because if you keep putting the negative, that keeps telling you to move it, right? So if you keep writing the negative when you move it down, it just tells you move it back up. Move it back, and it's a never-ending cycle. So when you actually do move it, it's no longer a negative power. Next one.
So that's just the final answer right there, like when you move it?
Actually, this one we can multiply out. I'm glad you said that. Negative 3, negative 3, negative 3, negative 3. Well, let's make it easy. What's negative 3 times 3?
9.
9 and 9 gives me 81. Positive because 4 negatives, right? Every 2 negatives make a positive. This one's a good one here. This is where people start really getting lost in the bigger problems when they mess these up. 5x to the negative 4th. I want to bring your attention to this 5. What is its power? 1. It does not have a negative power, does it? Only the x does. So when I move this, the only thing I'm moving is the x. The 5 stays put. Its power is 1. So this is 5 stays put, x to the 4th. Moves on down. Okay, that's where people really go wrong. Or, what I see a lot is, if this was a negative 5, they think it moves down. Just because it's a negative number doesn't mean anything if the negative power, not number. Okay, if the power is negative. Okay, so over here the whole thing gets moved on down at 2x. And I went ahead and got rid of those parentheses because it's to the 1. Well, everything's to the 1. Go. Like I said, my biggest concern is when I see this, I have people try to move the negative 3 down and make it positive as well. But it's a negative number, its power is still positive though. So it stays put. And let's go back down here. X to the 3rd over x to the 10th. Now here's where our rule or quotient rule is kind of helpful, but kind of not. Here's how you think about it. When I subtract those, what do I get? Negative 7. I can think about it as I have that, and then I can move it. Or I can think about it as, which one has more x's? The bottom. So when I cancel out, I'm still going to have more x's on the bottom, right? Think about it. This is really x, x, x. 1, 2, 3, 10 of those, right? When I cancel, there's going to be none left up top. There's going to be a whole lot on the bottom. And how many are going to be on the bottom? 7. So I can go ahead and put the 7 on the bottom. Positive 7. I can just kind of subtract, and if it's positive, put it up top. If it's negative, I can go ahead and put it on the bottom. It just tells me where the leftovers are. Same over here. It's going to be 4. Where's it going to be? Where the leftover is going to be? On the bottom. And how many? 3. Because 5 minus 2. Doesn't matter what order as long as you know that the leftover is on the bottom. Now 4 to the 3rd. What is 4 to the 3rd? I'll give you a minute to multiply it out if you need to. Not on a calculator.
64. Oh, wait.
Here are a bunch of different answers. I'm giving you a minute. I don't see hardly anyone writing. Not on the calculators. Guess what? There are no calculators this chapter, guys.
4 times 4 is 16 times. Yeah, 64.
It's 64.
What?
Because
Okay, never mind.
4 times 4 times 4? 16 times 4. Yeah.
Scared me there, Madison.
I was confused. I was doing 4 times 3 and I did that by
Okay, let's do some trickier ones. Well, this one is trickier, G. But not really if you've been paying attention all year. We shall see. This takes us back to some chapter 1 stuff. Okay, 3 to the negative 1. What is that really? That is not negative 3, that is 1/3, right? The negative power means move it down, right? Has nothing to do with the positive or negative. So over here, this is not 1/2, 1/2 squared, which is really 1/4, correct? Yes?
Yes.
And hey, I should know how to add fractions. How do you add fractions?
Straight across.
The common denominator. Guys, I'm assuming we covered this on a quiz. You need to know how to add and subtract fractions. What is my common denominator? 12. So up top, this one needs a times 4 times 3. So when I add, I get 7/12. That's a good problem right there. You have to know your exponent rules and you have to know your fraction rules. Good problem. Last one like that. Now, just because it's in the bottom means nothing. Remember, negative power means I switch places. So it's going up top. And there's nothing left on the bottom, which is 1. And I don't need an over 1 on the bottom. You need the ones on top, but you don't need the ones on the bottom. Yes? A little sample of everything.